Hello and welcome everyone to the fourth and the final part of this tutorial series in which I show you how to create realistic trees for games using the free software TreeIt. In part 3, I imported the trees to Unreal Engine and set up the materials. Now I will create the wind effect for the trees. As I mentioned earlier, the finished project can be downloaded from the link in the description below. The full Unreal Engine 5.1 project is in that link, as well as just the exported trees. If you don't want to implement the wind effect from scratch, go to the end of this video to find out how you can use the ready-made function from the downloadable project. This wind effect will consist of two parts. The first part will implement the sway of the trunk. As you can see, the trunk is swaying very slightly. And in the second part, I will create this effect of this subtle fluttering of the leaves. My implementation of wind is based on another project called Rural Australia by the artist Andrew Swanberg Hamilton. This project is available in the Unreal Engine marketplace and can be downloaded free of cost. So I will open the level with the trees that we prepared in the last part. I will start with the trunk. I will add a simple sway to the trunk so it rotates gently around its own axis. To keep it natural, I will make it dependent on the height, so the bottom will be completely static and the sway effect will increase the higher it goes. As I want to control the wind globally in the level, I will create a material parameter collection first. So let's go to the trees folder, right click and go to materials and add a material parameter collection. We will name it mpc underscore wind and let's open it up. We will add two scalar parameters like this. Let's name the first parameter to global wind strength, and the other one we will name sway amount. And for the global wind strength, the default value is 1 and sway amount is 2. And save. Now let's create a blueprint of actor class and name it bp underscore wind. Let's open it, and in the event graph, first let's create variables that we want to use. So the first variable is global wind strength, and this is a float, and turn this public symbol for it. Another variable which is the sway amount. So basically the same variables that we created for our material parameter collection, and also make the sway amount public. Let's drag both of them into the event graph and use the get function. And we want to decide what happens to the values in the material parameter collection when the level is being played. So let's call the set scalar parameter value function, connect it to the event begin play, and give it the parameter value from global wind strength and the parameter name. Now let's create a blueprint of class actor and name it bp_wind, and we will use this blueprint to control the values in the material parameter collection, which will in turn drive the values in the function, the material function that we will use to actually move the tree. And in this way, this blueprint can be used in the level to globally control the wind, and we then can control it very nicely and easily. So let's open the blueprint. Go to the event graph and let's create two variables. Let's name the first variable global wind strength. Oh, there's a typo. It's better. And another one, sway amount. So the same names as what we used in the material parameter collection. Both are floats. And also check this I symbol to make them public so that they can be used in the level. Now I want to connect these two variables with the material parameter collection. So let's use the setScalar parameter value function. So right click on this event graph and search for setScalar parameter value. And let's connect it to the event begin play so that it runs in the start. For this collection, let's select the MPC wind. Select the parameter name, global wind strength, and drag your global wind strength variable and use the get function and connect it to the parameter value. Also copy it with Ctrl D and select the other variable from the material parameter collection. Use the get also for the sway amount and connect it to parameter value. And don't forget to connect this control. So this will make the blueprint work when the level is being played. But to make it available all the time, copy these nodes and go to the construction script, paste, and copy and paste works with Ctrl C and Ctrl V easily. And then connect this execution to the construction script as well. Click save and compile. And now we can begin with the implementation in the material function. Let's go back and open the bark material. And let's create a new material function. And let's call it mf_sway. Let's open this material function and add a scalar param, and we will delete it later, but now it's needed to make it work as intended. Go back to the bark material and drag this material function. We need to save the function, and now it shows the output. So connect it to the world position offset in the material. So just a short description of how this effect works. Any value connected to the world position offset will actually move the vertices of our mesh. So just as an example, let's create a vector parameter, and these RGB values will act as XYZ in space. So put 100 in the B channel, which is the Z channel, essentially. Connect it to the world position offset and save. Let's go to the tree, and the bark or the trunk has now moved 100 units in the Z direction. And we can use this world position offset to create the wind effect. Let's connect it back to the material function sway, delete this vector parameter and save. So let's start to create this function. Open the function by double click and let's add the node rotate about world axis. This is a very handy built-in function to rotate any object around its world axis to the position that it has in the world or the level that we place in. And to make it work, we need to give it the world position. So drag this node out and search for world position. So the other input that we need is the pivot point around which we want our object to be rotated. And for the tree, we want to give this base as the pivot point, which is also the origin. So the 0, 0, 0 position for the tree mesh. So we can just give it straight away. So let's create a vector constant. And we can directly input this. This will work fine if we manually place our tree in the scene, but if we want to use it with foliage tool or use instances, then we need to use a conversion function. So let's create a node for transform position and connect it between the pivot point and the origin position, and click the transform position node, select the source as the instance and particle space, and output as the absolute world space. So this will make sure that if we use the trees with foliage or as instances, the correct position is given to the rotation function. So if the wind is not working with your trees, maybe this is the cause. For this rotation amount, we need an animated value. So let's call the sine function, and for the input of the sine, we will use the time input. Sine is a basic mathematical function which oscillates the value between 0 and 1 depending on an input, like this wave. And we don't need the complete rotation cycle. So let's divide the sine by, let's say, 4000 and connect it to the rotation amount instead. And let's connect the x-axis to the output. Save. And let's go to our tree. We can see the result now. It has started to sway a little bit, but this motion is really uniform and does not look natural at all. To make it look natural, we need to break it up a little bit. For this, I will use a second sine function and change its input a little bit and add the two sines, and then we will get a nice output like this graph shown here, and this will result in a much better rotation of the tree trunk. So I have added a second sine function now. For the input, I multiply and add some random value that I tested earlier. And now I will add the two sine outputs and then connect it to the division instead. And let's save it. I am also dividing the time now by 5 so that it's a bit slower. And let's also introduce our global parameter that we added earlier. So let's go into the content browser and drag this MPC wind, and from the left side select the parameter global wind strength, and let's add a multiply and multiply this to the output of this divide, and use this for the sine inputs. With this we can now control the speed of the wind in our level. So let's save it and let's go back to our level and wait till it saves and compiles the shaders again. In the level we can see that it's not moving at all, so let's drag this blueprint wind to the scene, and we see that the default values were not set, so let's set them in the blueprint. Select your variables and set the default values on the right hand side to 1, and also for the sway amount to 1. Compile and save. Go back to the level, and there is some motion now, and to make it faster we just need to increase this global wind strength value. So let's change it to 5, and we can see that how it works. And the rotation itself is not very uniform and looks quite natural. You can of course break it more and add more functions to make it more interesting, but just keep in mind the performance cost as well. I also want to use the other material parameter that we have to control the amount of sway. So let's go back to the function and copy this one and change the parameter to sway amount. Create a multiply and put this between this add from the two signs and the divide, and change this to 1000 so that it is a bit faster. So let's go back to the level, and the motion is a bit faster now, and if we select the BP wind we can see the sway amount, so let's increase it, and it works as well. So let's just use the value of 1 for now, or maybe increase the sway to 2. We can now organize our function a little bit. So let's just select all these nodes that work for the sway and right click, create comment from selection, and in the name let's just put sway, and let's select a blue color and delete this unused node and just organize it a little better. Like so. So now I want to regulate the rotation amount according to the height of the tree, so that there is no sway at the bottom of the tree and maximum at the top. For that, let's use the distance function, and we want to calculate the distance between the current vertex and the origin of the object. So the current vertex is actually the absolute world position, and the origin, as we already discussed, is this transform position. I then divide it by the object size, which is available through this function, object local bounds, and use a divide and divide it with the local bounds size output, and then multiply it with the rotation amount. So get the x-axis rotation and then connect it to the output. This then basically gives us a mask which has the value 0 at the bottom of the tree and 1 at the top, and this can then be used to scale the rotation amount with the multiply. And let's arrange it as well. Use the comment and just write mask lower part and make it red. We can go to the level to see its effect. So at the top it's swaying, and as we go to the bottom it becomes completely stationary. So now we can add this wave function to all of our other materials as well. So let's open the leaves material and let's find the sway function that we created. It's here, mf_sway. So just connect it to the world position offset. Also the bark2 material, same here, drag the function, connect to world position offset, and the stem material as well. Ctrl+Shift+S to save all, or file save all, and wait for it to recompile. So I noticed that sometimes this save all doesn't work. So just open all the materials one by one and click save. And if we go to our level now, the trees are nicely swaying. So the leaves are still looking a bit boring. So to add a much more interesting motion to them and some fluttering as well, I will use the vertex colors. And vertex colors are normally used to derive these kind of effects, and it works really well. TreeIt has already exported the trees with really great vertex colors, and we can look at them by using this debug material that I created. Let's assign this material to the tree material slots to see how the vertex colors look. With the vertex colors, we can encode different kind of information in the 3 color channels of R, G, and B. And I can use this debug material that I created to have a look at the vertex colors. If I connect this slot, we can have a look at the red vertex color, save it, and we can see that the value is 0 in the middle of the leaf and goes to 1 as we move out. Let's connect the green channel, and it just has a random value throughout, so it can be used to break the speed or the amount of the motion in the leaves. And let's look at the blue channel. So it appears that this is 0 at the start or the stem part of the leaves and goes to 1 as we move out. So we can use this information to get a more interesting motion for the leaves. So let's close this material and change it back. Let's open the leaves material. Let's create a new function in the content browser, materials, material function, mf leaves wind. Drag it to the material and let's open it. Just add a 0 input for it. Scalar. Let's go back to the leaves material, and it has an output now, and add it to the sway as well, so that whatever motion the leaves have, it is added to the sway, so that leaves are still connected to the branch or the bark of the tree. And hit save. Let's open the function, and now I want to create some animated random values, and as I want to use all three x, y and z axes for the leaves, I will use three sine functions, and I have speeded the next part up a little bit. So I ended up creating two sines and one cosine, and I also multiplied the global wind strength material parameter so that we can also control the strength of leaves motion from our level. So for the x, y and z values, I will use these three outputs. And to quickly visualize the output of your sine functions, I recommend to use this nice tool, graphtoy.com, and here you can just input your values and see how the resulting sine wave will look like. Let's create a vector from these inputs. I use the function makeFloat3 and just connect the x, y and z values. Let's connect this to the output and have a look at the results. So now we have more motion in the leaves, but we need to somehow control it better. And so if we remember, in the vertex colors, the blue channel had the value 0 in the starting stem of the leaves and 1 as it goes out. So we can use it to regulate the motion of the leaves better. So let's get our vertex colors by just using the vertex color node, get the blue channel and multiply it with the motion vector that we created. And it's better to use a power function for the blue channel. We will leave the value 2, which is by default, and this will just pronounce the effect more on the edges. And let's connect it to the output. So now it looks much better. Let's also scale the motion in z-axis by 2, so multiply it by 2, and also multiply the motion by the normal position, so that the motion follows the normal direction of the vertex. And this will create the motion in a much better way. So let's save it. To control the wind of the leaves separately from the bark. Let's add scalar parameter and name it wind strength and just multiply it with the output from the motion vector that we create. And this parameter can be used in the material instances of the leaves. Change the default value to 1 and we can delete this unused node. Now I want to create fluttering motion in the leaves, and for that I can use the red vertex color, which is 0 in the middle of the leaves and goes to 1 as we move outside. So let's go back to our material function and I will speed this up. So I reused the 3 sine outputs again, but I interchanged the axes so that the motion is a little better. I used the red channel from the vertex color to multiply it with, and also use the vertex normals to orient it better. Then I introduced a new scalar parameter so that we can control it from the material instance, and change the default value for this to 0.1. One thing that I almost forgot is to multiply the wind motion with the green channel so that the motion is randomly distributed among the leaves as well. And this is then much better. I can also multiply the output from the blue channel with 2 to make it more pronounced. I will also change the default values for leaf flutter to 2, like this. Save, and in the viewport the effect seems a little better now. I'm using for the blueprint, the default values are 0.5 and 0.5 for both of our control variables. You can obviously get very creative with it, add more variables and connect it to different parts in your function to have more control. You can also use different sine and cosine functions for the leaves flutter to make it independent, but performance will take a hit that way. I'll leave it like this for now and just organize it a little bit. So this is how it looks now. In the level editor, we can select the blueprint and change these values to see the effect and get the exact effect that we want. So let's try to increase the wind, maybe not so much, go back to 0.5, and we can also delete this debug tree now. So if you remember, we had 2 groups of leaves on the tree, so the healthy ones and the dead leaves, and with the material parameters that we defined in the function, we can decide the wind to affect the 2 different groups of leaves differently. So let's open the material instance for the dead leaves, and we see that the parameters are available here. So let's just dial down the leaves flutter and the wind strength also and hit save. So the reason is that the dead leaves will be heavier and will be then affected less from the wind. This was all. So if you skipped and don't want to create the material from scratch, you will need the material functions, which are starting with mf underscore and this material parameter collection underscore wind and the blueprint underscore wind. You need to attach the material functions in your material to the world position offset input. So for the bark material, only attach the sway material function, and for the leaves, attach both the sway and the leaves wind. So just add them and attach the output to the world position offset. And then in your scene, you can drag the blueprint underscore wind out into your scene, and you can then use these two variables to control the wind and the sway of the tree. So thanks for watching and hope you liked the video. If you have any questions, please leave it in the comments and I will try to answer. Please like the video and subscribe to my channel to give me more motivation to create interesting videos like this. Until next time, goodbye.